Good afternoon. Thank you very much for attending this forum from the Virtual Institute in Sustainable Cities and Communities. The way we organized it is the following. We have the representatives of each university in work package 6, and we will have presentations about each university, and so what is already going in each university in the topics related with this virtual institute. As we mentioned already, the Virtual Institute for Sustainable Cities and Communities will start with projects, research seed projects, mainly dedicated to two topics. The resilience of cities to heat waves, and also another topic related with cultural heritage buildings. And so we will have first I will talk about what are the activities in the University of Coimbra that are somehow related with these topics. I may say that I will talk in first place, not because I'm the coordinator, but because Coimbra is in the alphabetic order, the one appearing in first place. So in second place, we will have the University of EAGI, Professor Mihai Bulai. After we will have the University of Vienna, Professor Alexander Brennen. Next, Professor Marco Morandotti from Pavia. Next, Professor Miriam Lazar from the University of Poitiers. Next, Professor Juan José Rastrollo from Salamanca. And finally, from the University of Turku, because Turku is quite in the end of the alphabet, we will have Professor Yuka Kaikuk from that will be connecting online. So, as I think you may know already, we have, let me just put it here a little. One of our topics is the increasing the resilience of sensible groups to the effect of heat waves in European cities in a climate changing scenario. And the other project is the preservation and retrofitting of historical university buildings with relevant cultural heritage. So for both projects, we were able to find somehow a similar Gantt chart because the tasks are relatively similar, and these are like the indicators that we expect to have, like in terms of the presentations in conferences, master dissertations, scientific papers, seminars and workshops, and also the free mobility among the universities. Okay, and when we were planning, of course, it was in the time of pandemic, so we used these parentheses to put that this can be either physical, virtual, or blended. And we may say that we have at least already one indicator. So this week we had already the first presentation in a conference, not this forum, but in another conference. So it's a good start. So hopefully in the next forums that will be organized in the other universities, we may report about what is our position regarding these indicators. So in the University of Coimbra, let me say, we have a kind of a virtual institute, not a European virtual institute as we have here, but since 2008, we have what is called the Energy for Sustainability Initiative, that is very much the model of what we want here to the virtual institute. So we have about 100 scientists from many different areas, from all the departments of engineering, so civil, electrical, mechanical, chemical, and informatics, from the Department of Architecture, the Department of Earth Sciences, also from the Faculty of Economics, the Faculty of Law, and the Faculty of Psychology. So we have, as I was telling you, about 100 researchers that are collaborating in these topics, and we have a master program and a PhD program and a good number of research projects arising from this initiative. And we have also within this initiative a sustainable campus group, and so I will show you just some examples of research papers arising from this initiative. So this is very much related. This one I'm showing you, and it was published quite recently, about the overheating risk in Mediterranean residential buildings, and it's a comparison with the current and the future climate scenarios. And the two authors of this paper, they were former PhD students of our PhD in sustainable systems, sustainable energy systems. And nowadays they are like young researchers in our department. And they will sure be contributing to our... Okay, thank you. Yeah, okay. Yeah, so you see the team is working, so it's a collaborative work. Thank you very much, Mia. These are the cities that were evaluated in the Mediterranean area in the paper I was showing you. This is another recent paper. It's a review of the energy implications of passive building design and active measures under climate change in the Middle East. So it's like the first paper from one of our PhD students nowadays in the second year of her PhD. And okay, in our department, we have the right conditions to be like a case study for the type of work we need to conduct during the research seed project. So we have another European project about indoor air quality in school buildings, where we will be analyzing also the thermal characteristic, the thermal behavior of the building in different rooms. So this is like we will be measuring the temperature, the relative humidity, in terms of gases, carbon monoxide and carbon dioxide. We will be measuring also particles, the lighting conditions, and also some microbiologic measurements that nowadays are really important, and besides that, the noise. And this type of measurements is also is already being carried out in a few buildings that we consider as cultural heritage buildings. So this is like a project that is being granted by the university itself because, you know, tourism is a very important source of income in the university. So we have the old part of the university is let's say a cultural heritage area for UNESCO, and we are receiving many tourists, and so there is like a trade-off between having many tourists and preserving the books and the paintings and so on. And so since some years, this is like a main topic of research from Dr. Luisa, who is in our team. And so, as you see, we are like analyzing different variables, and we are checking the effects of like the waves of tourists entering in the building. So, and there were already some measures to correct this effect, like the way the visits are organized and so on. And so this is like a paper published in the Journal of Cultural Heritage, together with some colleagues from the University of Pisa, because they have a similar project running in their university. This is another building, so a little bit somehow like here in Salamanca. We also have many old buildings in the university, and so I think it's quite easy to find case studies in our universities for a project like this one. Okay, this is like a museum, and this is the type of sensors that the location of all the sensors that have been installed and where we are collecting data. So this is the Natural History Museum. So, and it's another paper about the importance of long-term hydrothermal assessments, and just some other pictures. So I think that's all for to show what are our running projects. It's of course a small group of examples. We could find more, but I think they are enough to show to what we want to show here. So I think, okay, we may have like one or two questions if someone wants to ask some question, even from the table or from the public. No questions for the moment. So, okay, this I may. Yeah. And now I will put this presentation and okay. Yeah, I give you this and you
right?
yes, this one to and
Okay. Hello, everyone. My name is Mihai Bulai. I come from the University of Iași, which is called Alexander Ioan Cuza University. We are located at the eastern border of European Union, but actually in the center of Europe. Iași is a 400,000 inhabitant city, so 3 times bigger than Salamanca. It's very similar to Salamanca because it's a city of youth, city of parks and green. And also it represents a cultural capital of Romania. Culture, students, and history are the basis of the functioning of our city. The University of Iași is the oldest modern establishment of universities in Romania, although our first academias can be traced back to 16th century. Of course, not 13th century like Salamanca, but still an important history related to academia. Our research team in Iași, formed by one human geographer, which is myself, one physical geographer and climatologist, and one chemist, are bringing our contribution to the work package 6 under the direction of Coimbra University. Our expertise, and not just the core team, but our departments of geography and chemistry are planning to have an important contribution to the creation of the Virtual Institute Master Program, and the introduction to the sustainable cities and communities and the governance in the sustainable cities and communities, 2 important and foundation courses in this master degree will also be supported potentially by the topics I mentioned in this attached slide, such as the air quality, noise and waste management, transportation systems and mobility, very good expertise in natural disasters and implications for people and for territorial planning. Access to public spaces, this is actually a very important topic today in Romania, but also across Europe, as well as the development planning at national and regional level. We're still learning about governance. We're not as advanced as the Western Europe, but we would also like to learn a lot from this collaboration, apart from bringing our contribution. And I believe our contribution will be essential in the research seed project A, or 1, called Resilience to Heat Waves. We already have an important scientific work regarding the urban heat island and regarding the heat waves. Our contribution will be in mapping and forecasting heat waves, producing indicators to generate alerts. We have already established some monitoring sensors that collects data and also we have a good tradition in approaching policymakers and define guidelines for the future strategies and planning. Of course, the expertise is much larger. It goes from the summer heat waves, urban heat island, extreme temperatures, weather conditions that have had an influence on COVID-19 outbreak and also COVID-19 waves in Europe. I made with bolder letters the keywords in this presentation. Perception of risk, variability of air pollutants such as nitrogen oxides and O3, measurement techniques, and of course detection of O3 in the atmosphere. That's just some quick research that I spotted that are relevant and are useful for the research seed projects. Our expertise is not just research, but also our existing collaboration with the stakeholders and decision makers. We have got closer to the municipal, to the city hall and to the decision makers, such as our university has elaborated the tourism strategy of the city and the metropolitan area. We have given and we are giving now an important contribution to the strategy of urban development and plans for sustainable urban mobilities. And we are very often consulted, or we involve ourselves in the public policies, such as the noise map, pollution map, or pollution with particle matters 2.5 or 10 and other pollutants. Our methods and instruments range from cartography, remote sensing, GIS analysis, modeling, and weather stations and sensors and other sensors that can collect data. Our expected heritage, that was an interesting question that our work package leader addressed to us. What's our heritage after 3 years of ongoing project? And I believe the most important heritage will be about consolidating our collaboration inside the consortium of the 7 universities. So my dream is to have like 7 universities, but just one actually functioning very well together. Also, I would like to leave some methods and some possibilities to tackle future issues in the post-COVID era. We would like to learn a lot from this period of time and to become more resilient. We would also like to increase our role and legitimacy in formulating guidelines, policy making, and even going up to empowerment. Also introducing key issues such as heat waves and urban heat island in the curricula. Sometimes our curricula is very general. It just spans of general concepts, and we never go to some specific matters like that unless the student is going up to a PhD level. Of course, we would like to support master and PhD students in adopting more of such crucial themes in their thesis, and to support more and more joint PhD theses between our universities. That will be my presentation, and of course, I'm open to questions. And in case your exploration will increase in the next months, I invite you to visit Romania and explore the Carpathian Garden, as we would like to say. Thank you.
Thank you very much, Mihai, for the interesting presentation and for showing us this last picture that increases strongly our wish to visit Romania. I think we can proceed and to have a discussion period in the end, if you agree. Is it okay?
Where's their feedback?
Can use yours, yeah. No, this one looks to be better in terms of feedback.
Let's see if the cable is okay. Let's try this. Can you hear me well? Okay, so let's move on to Jena, the science and technology town in eastern central Germany, located beautifully in the Saale Valley. There are vineyards nearby. There's a very pleasant climate in these lowlands, although we're still also close to a mountain range with cross-country skiing opportunities in winter. So very exciting place, both in terms of science and technology, but also the nature around it in the green heart of Germany. My name is Alexander Brennen. I represent the Geographic Information Science group within the Geography Department of the University of Jena. So another geographer within this multidisciplinary group that covers this complex topic. And what I bring to the table is mostly methodological contributions that we can use to solve geographical or sustainability problems. And GI science is geographic information science, or in other words, basically geospatial data science, to use a more modern concept that's also used outside of geography. So we're interested in the methods behind solutions to geographical or geospatial problems. And we also apply these methods in a variety of contexts. A quick look at our team, but also at the geography department as a whole. So I'm not showing the entire department here. It's a comprehensive department covering all fields within the subject of geography, from human geography to physical and geomatics. And the pictures show the more senior members of my group, especially the ones with PhD, and in the top, in the middle, Bettina Böhm. She's also here, and she's currently also funded through EC2U with the generous support of the university. So we have very strong woman power in our group to strengthen the activities that we bring into this virtual institute. So maybe a brief look at some of the other groups within our department. There's economic geography, which works on a variety of sustainability topics, regional dynamics and spatial management related to office space, but also housing in central Germany and elsewhere. They look at climate adaptation and sustainability, and I'll list a couple projects of theirs in a few minutes. There's physical geography, which looks at climate and environmental change, mainly at timescales of thousands to tens of thousands of years, but also with an eye on how climate is currently changing and how future changes will affect our lives. and in Earth observation, with which we closely collaborate, especially in the graduate program on geomatics or geographic information science. Of course, there's Earth observation of environmental change, and finally social geography, another important field where human dimensions of related to mobility, for example, and safety and security are explored. Looking at some of the research themes within our group, the GI Science group, just a brief overview, a couple insights to maybe start further conversations. So looking at more fundamental research, I'm especially personally interested, since my background is in geostatistics, at the challenges of applying machine learning methods to geospatial data, which are manifold, related to spatial autocorrelation, related to interpretability of models, but also related to the assessment of models that are applied to spatially predict features. Here I'm showing some figures from a recently submitted and gladly positively evaluated paper, which looks at the spatial prediction behavior of geostatistical versus machine learning techniques in several case studies. So trying to add the spatial dimensions to machine learning techniques, which are usually agnostic of the spatial characteristics of the problem at hand. So try to understand better why some of these models fail when applied to spatial prediction problems, and which methods, how they can be modified, how they can be made more promising. These methods are also applied to a variety of applications. I'll get back to that in a second. But first, maybe another look at this next bullet item, spatial temporal trend detection, which is a field in which we closely collaborate with the Max Planck Institute for biogeochemistry in Jena. So Jena has as part of the Jena-versum, I guess, the Jena-verse, an ecosystem of cutting-edge research centers, Max Planck Institutes, and we in geography and my group in particular, we very closely collaborate with the Max Planck Institute for biogeochemistry, especially for continental to global scale geospatial analyses of environmental change. And so one jointly supervised PhD student, Jose Cortez, he looks at methods for better assessing statistically significant trends in spatial time series, which some of you may not be aware of this problem, come with a multiple testing problem. So this kind of data mining challenge has to be tackled to obtain statistically valid results from this statistical perspective of adjusting for multiplicity in tests. And we're adopting actually methods from neuroimaging to the geospatial context to, in this case, which was recently published in a high-ranking journal, to assess greening and browning trends, in this case only greening trends in leaf area index time series across the globe. So these are the statistically reliable areas that are being highlighted. Another very important area of our research relates to the application of the machine learning methods mentioned previously, especially to Earth surface processes such as landslides to model landslide susceptibility, landslide runout or debris flow runout, in this case, a study from the Chilean Andes. So a challenge here is, again, to make these models transferable to other areas, maybe to future climate scenarios, to make them physically meaningful and interpretable. So to develop hybrid models that incorporate physical knowledge of the mechanical processes governing slope stability while achieving optimal predictive performance. Then there's an overlap with the large field of ecohydrological modeling that we're working on, in that we're also looking at process-based, physically based or conceptual models of debris flow activity and of hydrological processes, especially under the effect of climate change and land use change, both in the past, but also looking into the future and applying future climate scenarios to these models. Looking at some concrete research projects that are ongoing or recently finished. So we recently got green light for an ELIS unit. So ELIS, what was that again? European Laboratories for Learning and Intelligent Systems. Yes, so these are networks of research groups, in this case involving ourselves, the Max Planck Institute, and the DLR Institute for Data Science, which is also located in Jena. And we all jointly look at machine learning enabled understanding of environmental systems of the Earth system. Then looking more at the process-based side, there are two projects, Driver and TIPEC, looking in different regions across the globe at hydrological processes under climate and land use change. And for landslides, we recently completed two projects with Austrian partners on landslides. Economic geography, as I mentioned, there are ongoing projects on intermunicipal housing concepts for sustainable land management, or on a platform for climate compliant action at the municipal and county level in the region. And so please reach out to us, reach out to them, so we can activate these colleagues, which are not initially part of this network, but which we really very much want to get more closely linked into this virtual institute. A couple words on ongoing activities. So related to the seed project on resilience of cities to heat waves, we are currently exploring a co-hotel between our group and the universities of Turku and Iași to further establish this topic within our virtual institute. So we're currently looking at the administrative topics, and Yuka, I look forward also to discussing with you the possible research focus of that position. There's also another currently ongoing co-supervision with the Max Planck Institute for Biogeochemistry in Jena. Became part of the supervisory committee recently, and I'm trying to pull this student into this virtual institute because she's really a great match. She's looking at societal attention to heat waves. So for example, how do Google searches, but also online and print media attention relate to and focusing on heat waves as well as heat stroke as two particular subfields. How do they relate to temperature extremes? So in how far does societal attention, does also hospitalization and mortality relate to the meteorological observations? And I also look forward to further discussions with other members of EC2U on this field. Other research activities which relate to this network. I'm in touch with Professor Merker at Pavia. He's a physical geographer working on soil erosion and landslides. So we look forward to receiving one of his PhD students in our group very soon for about half a year. And we're also starting to explore common research interests with Professor Nikolica in Iași. So I think there are great possibilities, maybe even trilateral opportunities for joint research. I should probably start to wrap up. So this is my almost last slide. Just a couple words on teaching and outreach. So we are in touch with the city of Jena, trying to establish links to the Smart City Jena project, a very, very large project which runs until 2027. So we're still in an early exploration phase here to find joint topics. In teaching and outreach, we're offering a GIS Day event. So GIS is Geographic Information Science or Systems Day in mid-November, gladly for the first time with contributions from Turku and Iași. And we applied for a DAAD summer school for next September on geospatial data science using R, which will have reserved spots for participants from this virtual institute of the Alliance. Yeah, and that was previously presented yesterday. We have a contribution to work package 7 related to high schools and heat wave related use of Earth observation. Just a couple quick slides on a recent master thesis on the topic of heat waves. So we used, in collaboration with the Thuringian Climate Agency, which is also located in Jena, from a pilot project they're running in Jena, we used mobile as well as stationary sensor data, mobile data that's mounted on trains, to collect at a spatial and temporally very high resolution temperature data. We used this for geostatistical interpolation of temperatures, and as we can see, there are certain challenges. You see that on the image to the left. Of course, all these points should be on the tram line and not 10 meters next to it. So, of course, there are some positional challenges, pre-processing challenges, geostatistical challenges in analyzing this data. But we got some very promising first results, and I hope that this is a valuable experience also looking at the seed project that we will explore in the future. And finally, as a take-home message, please come to our GIS Day, which is a hybrid event, so you can attend virtually from wherever you are. Thank you.
Thank you very much, Alexander. So now it's to Marco. Just a second to. Okay.
Okay, so thanks for the possibility to show you all some ongoing research topics that we are developing at the Department of Civil Engineering of the University of Pavia. We are a group that focus mostly about researches dealing with cultural heritage preservation and valorization. So this could be also the contribution that we may carry on during this experience. And I every time remember the very first time in which I discussed with Ludovic about the idea to join universities across Europe, coming from a long path of history, dealing with the same problems of using and reusing and protecting heritage, dealing of the university. It was 2016, I suppose, in Poitiers during a Coimbra group meeting. So I am very happy to see that after a lot of work, we are now here trying to translate into truth this kind of dream that we had many years ago. And within the research group in Pavia, we strongly work in a global approach to cultural heritage preservation and valorization. That means having an approach that is multidisciplinary, multi-level and multi-scaled and strongly integrated among different competencies. In our group and in our department, we are both engineer, architect, historians, physics, and so many of these competencies will also find a path along the researches that obviously we are developing, and hopefully we may develop all together. Of course, there is no time to deepen this kind of approach, but the point is that it takes into consideration building, the possibility of reuse, building or make it functional to new requirements, and city as a whole. So we usually have this kind of multi-level approach, including, for instance, urban planning, historical analysis, and of course, more technical approaches. I decided to select here a short amount of ongoing researches that may overlap with some topics on this table and may hopefully be interesting for new cooperation among this alliance. The first one is a research that I am developing since few years right now, and is focused on the aim to define a tool, so an instrument to support decision in the field of reuse of existing historical building, using an approach based on resilience evaluation. So the idea to find and evaluate indicators that are evidence-based in order to evaluate in a very early stage the impact of transformation of historical and existing buildings in order to develop the most sustainable approach to the reuse. So of course it's clear the connection with circular economy, optimization of behavior, enhancement of performance, and so on. And to do so, we usually define modeling of existing building, and we are testing some technologies to test and make more effective the scan-to-beam approach in order to make a complete survey of, for instance, these are topics taken from the cultural heritage real estate of the University of Pavia and some of the colleges of the university, in the perspective to generate, also in this case, instrument useful for planet conservation and facility management of historical building. And so it seems clear to me the possible integration with the topic of evaluate the pressure of use of users within historical buildings in terms to predetermine the impact of use versus conservation, or the managing of the intervention, or climate evaluation. So the idea is to stress a lot virtual modeling also for historical culture, and we are also planning to open a new master degree on this topic of virtual architecture and modeling, obviously in the perspective of instruments to assess a management of historical buildings. We are also more specifically and technically research dealing with thermal behavior of existing building, with especially a colleague of us that deals more specifically with this topic, but many times we develop joint researches in order to connect specific approaches in a much more holistic, if possible, way. For instance, this one is a PhD thesis discussed a few months ago. In this work, we have developed, Cristina Cecchini was the author of the thesis, and we followed both from an energetical and technological and technical point of view, a linking between GIS and BIM modeling. So the idea to mapping, for instance, here is the city center of Pavia, and overlapping to this 3D map a huge amount of information, trying to select them. For instance, in this picture, there is the thermal behavior of existing building, both housing, so private, and the university building at the wall. And we developed some kind of approach of optimization of improvement of the energetical performance of the building, taking into account performance and cost. So it's cost efficiency scheme. Finally, a couple of examples of didactic activities that we are going to develop that take the same and use the same integrated approach. This is Be Sure winter school that we are going to have in the next January. Of course, it is open to all the University of the Alliance because it has been designed having into the perspective the Virtual Institute activities, and of course this will focus to topic of urban sustainability, energy retrofitting, sustainable reuse, and innovative technologies for heritage preservation. And so I really do hope, and I'm going to close, that starting from these opportunities to share experiences and perspective, we may generate further cooperation and collaboration, not only on didactic front, but also on scientific-based activities. And the same transversal approach we also used in a short course, that's an open badge course that is it's been finished a few days ago, focused on sustainable cities and communities, the SDG 11 target we all know. And also in this case, the main topics were urban space planning, sustainable improvement and thermal behavior, and integrate sustainable approach and preservation of historical heritage. So I'm finished my 7 minutes, and so thanks for your attention, and of course we are here to answer to your questions. Thanks.
Yeah. Thank you, Manuel, for giving me the floor. So I'm Myriam Lazare from University of Poitiers, and on the first slide you can see one of the buildings belonging to the university called NC Poitiers. It's an engineering school dedicated to environment, energy, and civil engineering. So to this school and to the work package 6, there are mainly 3 laboratories linked with the topics of WP6, named EC2MP, LIAS, and also Institut P', which deals for the last one with mechanics, fluids, and also heat transfer. So I will present you a brief overview of 2 main subjects. The first one deals with the thermal behavior of the buildings, and second one investigates the means to recover energy of the building. So a part of the study was also supported by CPER FEDER, la Nouvelle-Aquitaine et l'Europe. So for the next slide, it is very important in France because we have many thermal regulation. The first one, the real one, was in 2005, and we can say that many of the buildings in France are not very efficient because the energy consumption is very high, is too high. So here you can see that the old building means built before 1975 are very bad as energy point of view, and we have to improve this building. And the main reason is that they have insufficient thermal insulation to maintain the thermal comforts in winter, but also in summer. So there is really a need for more heating and cooling in winter and summer. We have also to consider the gas emission, and you have to know that the buildings are contributing to 30% of the global gas emission. So it's really a lot. And a lot of effort must be done in order to decrease the gas emission. So, in order to achieve this aim, we decided to focus on dynamic thermal simulation. That means that you will perform simulation in order to have the transient evolution of the temperature of a building. Here you can see on the map, the France is divided in many areas, depending mainly on weather condition. And when you have the map of the building, you can plot a 2D view or also a 3D-dimensional view of the building. Here is only represented one building, but we can also do it for many buildings and also a town, a whole town. And it's very interesting to change the weather condition because you can choose the city, and also in terms of temperature, humidity, and also solar emission. And it is interesting also to investigate the influence of heating. For instance, we are interested to heat at 19 degrees or 18 degrees, and we can see that you can make a lot of saving by decreasing the temperature of heating of only 1 degree. We can also have result in terms of temperature during a whole year, and on the figure you can see the temperature in a room and also the temperature outside. It's very efficient to see if people in the house are very comfortable or not. We can see that also with the Bragger zone. Now I will speak about thermoelectricity. So in order to improve the energy performance of a building, it's really adequate to use renewable energy technologies to recover, for instance, waste heat and to produce electricity. And in that case, thermal element could be used for air conditioning, but also for heating, cooling a room office. And this topic is investigated by a PhD student, Renato Barbosa Esteves. And the aim is to see how many energy could be saved thanks to this mean, and to estimate the performance of the thermal element, numerical simulation could be performed. And of course, a lot of equation must be used in terms of quantity of heat, but also temperature and also the power which could be recovered depending on the main characteristic of the thermal element. And what also we try to do in our team is to try to optimize the design of the module in order to obtain more power generated. So I will switch to the last slide. There are many ways to adapt. There are many ways to. Sorry about that.
Too many technologies.
Too many technologies. Yeah, too many computers. So concerning dynamic thermal simulation, I think up to now we only were interested by what happened in France, but it will also be interesting to investigate different weather conditions, so we can also choose cities in other countries, and it would be interesting to choose between the 7 countries of the Alliance. And here we talk about simulation, and it will also be interesting to compare the result of the simulation with the real data, which will be measured with sensor in the topic A of this virtual institute. And one point very important is also to investigate the comfort of the inhabitant with the Bragger zone. And it will be also interesting to simulate the influence of the climate change by, for instance, changing the weather condition, to extrapolate the weather condition in order to see the new temperature in the building. And concerning the topic of thermoelectricity for heat recovery in the building, we could also investigate different weather conditions in our city. So thank you for giving me the floor. That's it for me.
Very much. It's okay. We will sure have the possibility of merging many different ideas in some project. And now we have presentation number 6 from Salamanca. Could you give me the? Yes, you need the. We will give you the control.
Thank you very much. Well, I am Juan José Rastorio Suárez. I am professor of administrative law in Salamanca University in the Faculty of Law, and I am the coordinator of a group of social scientists. For example, Agustín Ferrar, which is there, he's a political scientist. I am a lawyer, and another friend, Daniel Terrón, which is a lawyer like me. So we are a singular group here in WP6, and I wanna make a brief intervention about one of our upcoming articles, upcoming papers, based in one of our line of research. My intervention is about European urban planning through the years. Well, urban planning has been a concern of continental dimensions in Europe for several decades, and it has been linked from the beginning with the need to avoid unsustainable and irrational urban development. One of the first documents where this concern is expressed corresponds to the 1972 European Soil Charter adopted by the Council of Europe in Strasbourg. The Soil Charter outlined fundamental principles of sustainable land and urban development by warning of necessity to conceive land use planning policy in terms of the needs of the current and future populations, and to promote scientific research and interdisciplinary collaboration in order to encourage the rational use of resources. Article 7 of the Charter addresses specifically urban development, urban waste, pollution, and natural reserves. This first document was not further developed until 11 years later. In 1983, the European Special Planning Charter, also known as the Torremolinos Charter, was adopted by the Council of Europe in that Spanish town. The Charter defined the concept of spatial planning under an European perspective, establishing as crucial dimensions of the concept its democratic, global, functional, and future-oriented characteristics. In developing of the principles first suggested in 1972, the Torremolinos Charter called for the responsible management of natural resources, the protection of the environment, and the rational use of the territory. During the 1980s, a strong international movement began to grow, focusing on the impact that economic and urban development without proper controls was having on the global environment. A reference document in this regard corresponds to the 1987 or Common Future or Broadland Report. Promoted by the United Nations, the report proposes for the first time a definition of sustainable development or sustainability as meeting the needs of the present generation without compromising the ability of future generations to meet their own needs. By 1919, in the European Union, the Green Paper on the Urban Environment, a communication from the Commission to the Council and the Parliament, highlighted both the European model of the city and social cohesion as constituent element of a specifically European approach to cities. Although urban policy is not strictly a part of the European Union's sphere of responsibilities, the area has been largely taken over by the Council of Europe regarding the concern for sustainable urban development. Moreover, it can be affirmed that the Union has several indirect or incidental responsibilities in the field of spatial planning. The European model of urban planning has been opposed to the characteristically Anglo-Saxon model of the diffuse city, characterized by expansionism, the separation between residential, business, and industrial centers, and the massive use of transportation. The European model has been linked to a different idea of sustainability that involves taking advantage of the existing city, preserving it as a space for coexistence, and as essential component of the identity of human communities. The concept of social cohesion is addressed by Article 4.2 of the Treaty of the Functioning of European Union, and it represents one of the main areas in which responsibilities are shared between the European Union and the member states. The concept of social cohesion corresponds also to the European model of urban planning, which aims at integration and coexistence and seeks to avoid segregation. Furthermore, the Green Paper on the urban environment passed as a communication from the Commission to the Council and Parliament in 1919, establishes as guidelines for the improvement of the urban environment in Europe the principles of coordination, integration, responsibility, sustainability, and subsidiarity. The Charter of European Cities of Arbor, or Arbor Charter, adopted by the European Commission in 1994 and approved by the participants in the European Conference of Sustainable Cities, took a further step forward by proclaiming the need for the future development of Europe's cities to revolve around the concept of sustainability. This notion, which from that time onwards was to condition European urban planning, was defined in the Charter in relation to many different areas such as the economy, social justice, mobility, citizen participation, and the strengthening of democracy and the environment. During the 19th and the 2000s, the United Nations continued to push sustainable development to the forefront of the international political agenda. First, the Rio de Janeiro Summit in 1992 and the subsequent adoption of Agenda 21, and then the Johannesburg Summit in 2002 and the subsequent adoption of the Program of Implementation began to define concrete actions to ensure the preservation of the principle of sustainable development with a global approach. In 2007, the European Union Territorial Agenda added new variables to the process of building a European urban planning concept based on the idea of sustainability. Further emphasis was placed on the strengthening of regional identities and the need to combine this with innovation through the creation of clusters and other mechanism integration, through the creation of networks of urban regions and cities, trans-European networks, new forms of associations, and regional governance between rural and urban areas, or action for cooperation between the European Commission and the Member States. In this permanent and cooperative process aimed at territorial cohesion, it is essential to promote the environment through trans-European risk management, including the impacts of climate change or the strengthening of ecological structures and cultural resources as added value for development. The Leipzig Charter of the same year specified these objectives at the city level, emphasizing the need to materialize sustainability in the achievement of integrated urban development and paying special attention to the most disadvantaged neighborhoods. To this end, the objectives were formulated as supporting the modernization of infrastructures and promoting innovation, paying special attention to the local economy and education, and creating and consolidating quality public spaces. The economic crisis of 2008 and its implication for urban planning, particularly in Spain, pushed the different ministers of the Union with competences in the matter, thusing the Toledo Declaration of 2010, in which they clearly identified the need to link the future development of urban planning to urban regeneration, which would end at being projected in the Spanish urban planning legislation since 2013 with the passing of the Law on Urban Rehabilitation, Regeneration and Renovation, which will become the central element of legislation on urban planning in Spain during the following years. At the same time, in 2007, the European Union strengthened its capacity for action in this area through the inclusion in the Treaty of Lisbon of the reference to territorial cohesion, together with economic and social cohesion, which already formed part of Article 4.2 of the Treaty of the Functioning of the European Union as a shared competence between the European Union and the Member States. This reference changes, at least partially, the notion that the European Union has no competence whatsoever in the field of urban policies. It has become clear that urban policy is at least a responsibility shared between the European Union and the Member States. Since then, the projection of sustainable urbanism in the Union will go hand in hand with the principle of subsidiarity. First of all, and secondly, with environmental competencies, which will become the legal foundation from which to articulate policies with an impact on urbanism in the Member States. Under the first principle, the institution closest to the citizens and the ones that should have the greatest capacity to make decisions affecting urban planning, as they are the ones that best know the reality close to the citizens, and because they are an essential instrument of democratic participation. The second principle leads to different programs that have been implemented, including environmental impact assessment and the regulation of public participation as the framework for urban planning in an homogeneous manner through Europe. European urban planning will be conditioned not only by the principle of sustainable development, but also by the global dimension of this principle, which will become increasingly evident. In this sense, it's important not to lose sight of the main objectives set at the Rio Heart Summit in 2012 to ensure its international projection based on the development of a green economy, the eradication of poverty, and the maintenance of a sufficiently solid institutional framework to make possible and its projection into future. The 2016 Pact of Amsterdam was the gateway to European urbanism in the third decade of the 21st century. From it, a new urban agenda is designed in the European Union, characterized by three objectives: regulatory improvement regarding urban areas, improvement in the design and management of financing instruments, and the promotion of knowledge exchange, and which has multi-level governance as a distinctive feature. In 2020, the new Leipzig Charter 2020 was approved, and as a consequence, the Territorial Agenda 2030. The new reference document of European urbanism is based on the concept of the common good and the transformative role that cities have reserved for their attainment. The Charter delves into the three interrelated dimensions that have been addressed over the years in various documents mentioned above: social, environmental, and economic, although placing them in the perspective of the new challenges facing European societies, such as climate change, the consequences of the health crisis caused by COVID-19, or the intensification of migratory flows. The new Leipzig Charter mentions three dimensions: just, green, and productive. With regard to the social dimensions, when speaking of the EU city, it stresses the need to facilitate equal opportunities, access to public service, and decent housing for all, regardless of personal conditions. With regard to the environment, when mentioning the Green City, the Leipzig Charter underlines the need to combine the future evolution of urban planning with the fight against climate change based on innovation. With regard to the economic issues, the Leipzig Charter focuses on the productive city, a diversified economy that generates jobs and favors innovation. In summary, one of the main contributions offered by the new Leipzig Charter in the reference to the principle for good governance in cities, which the Charter defines as a series of strategic goals. Among them, the Charter mentions urban policies for the common good, providing services and infrastructure to materialize it, integrated approach in the spatial, sectorial, and temporal dimensions, participation and co-creation, promoting the participation of urban agents and citizens to strengthen local democracy, multi-level governance in accordance with the principles of subsidiarity and proportionality involving the local, regional, metropolitan, national, European, and global levels, and a specialized approach, taking into account the characteristics reality of each territory. In direct connection with the Leipzig Charter, the territorial strategy, A Future for All Places, was approved. As its name suggests, this new version intersects with the United Nations agenda so that its purposes are directly linked to the Sustainable Development Goals. As a further development of previous document, the territorial strategy stresses the need to achieve a fairer Europe, promoting territorial balances, integration between regions and functional areas, and cross-border integration, and a greener Europe, which, in addition to resilience and climate change, promote the circular economy, sustainable connectivity, and digitalization. With the main goal of limiting inequality and fostering sustainable development, the strategy calls for informal multi-level cooperation of a number of key players: the member states, subnational authorities, the European Commission, the European Parliament, the European Committee of the Regions, the European Economic and Social Committee, the European Investment Bank, and other European and national associations. As a final remark, I hope my brief summary of documents can help to understand the origins and the development of urban planning as a public policy area in Europe. We have seen more and more integration of policy principles during the past year at the European level, as well as a definition of goals that become more ambitious and more inspired. In fact, the current situation of urban development and the challenges ahead require no less of public policy practitioners and of or Forum of European Universities. Thank you very much for your attention.
Good evening, Manuel. Can you hear me?
Yes.
Excellent. Yes, yes. Okay. If you prefer, I can indeed share my screen. Let me just double check that I have my presentation open at this end. It is. Yes.
Yeah, we have it already.
Okay. So it works.
Yes.
Lovely, lovely. Good evening, everyone, dear colleagues and the audience. And please accept my apologies for not being present there. I really envy you in the warm south. It's pretty dull and autumnal weather already up here in Finland. But unfortunately, I couldn't afford. My schedule didn't allow me to travel to Salamanca this time. I also clearly did not take the opportunity to give a nice presentation, kind of advertising our university or the activities, but I have rather focused now on the one topic, which is the resilience of cities to heat waves and what we are actually doing in Turku. So apologies for that. Please talk to my colleagues who are there present if you want to hear more about our university activities. So basically what we do have in Turku, as you saw in the previous slide, I come from the Department of Geography and Geology. So yet another geographer on the line here. And in geography, we have hosted the so-called Turklim network, which is Turku Urban Climate Research Group network of weather observations in Turku. And on the right-hand side, you can see the map of the Turku area. So Turku is about 180,000 inhabitants, sort of middle-sized city. It's the 6th biggest in Finland. It's also the former capital of Finland, and it is the oldest city in Finland, already established in the 12th century. So we will be 850 years old soon. And but as you can see, the photo on the left-hand side, which shows one of our weather stations live, there shows that not all of our buildings date very long time back. So basically, what we do have in Turku is a network of 75 weather loggers installed at 3-meter elevation, and all of these monitor temperature and relative humidity in half-an-hour interval. So we get over 1 million observations per year. And Turku is located on the coast, as you can see here on the map on the right-hand side, and we have a large archipelago, lots of islands surrounding the coastal area. So basically what we have been doing now during the last 20 years or so, since I was a young lecturer in Turku when we established this network, we have been modeling the urban heat island, basically. So basically what we do here is we use various environmental factors like land use, topography and water bodies in order to understand how these affect the temperature and humidity. We use GIS datasets like Corin land cover, slices, which is a national, more detailed land cover classification, digital elevation model, various satellite data as well. And then we use various modeling methods in order to produce these maps like regression models and so forth, as you can see on that bulleted list. So what can be done based on these quite large number of point data, we can produce continuous maps of temperature. And I have selected here a few examples now, 5 different cases. This is from a sort of heat wave situation in summertime. This is a very cold winter day. As you can see here, we have like 21 to 29 degrees minus there. And then we have a situation with large temperature differences, which is a situation during sort of autumn time when the sea is still warm and we get sort of warm temperatures by the coast and then cooler in the inland and so forth. So we can actually produce these maps reliably, and that is a strength, and that these have been used in city planning quite vastly. What I wanted to say a few words about is the current project that we are now running. It's funded by the Academy of Finland, the national funding agency. They have a program on climate change and health running at the moment, and there are some half a dozen large projects funded through this, and I'm the principal investigator of a consortium. We call ourselves Hercules. It's health risk and climate change, understanding links between exposure, hazards, and vulnerability. And our focus in our project is that when we have the climate change affecting the urban, people are actually currently much longer. This was the original phase, but we have now been able to hire more people here. And what the key ideas of Hercules is that we want to understand the spatial pattern and intensity of the health-relevant climatic hazards, and also other environmental exposures, such as the sort of green areas, how the green affects people, and how these have changed in the 1980s until today, and also how they will change in the future, sort of mid-century timescale. And we have actually a patient data of over 50,000 people in Finland. So we have quite large cohort that we can combine the climate information with this health information. We are actually not only working in Turku, but we are covering the 6 biggest cities in Finland, including the capital region, Helsinki, Espoo, and Vantaa. They form the capital region, and then 3 other cities in Turku. So what we want to do is to develop a model of kind of policy outcomes and trends in urban development that affect then the sort of how the city is evolving. And the idea is that we support decision making for healthier urban environments under changing climate. So this is what we are currently doing in terms of heat waves, and we have several manuscripts now under construction, which will be submitted within the next 6 months. But there is still plenty of room if we consider the potential PhD candidates who might be able to join our team. I've listed a few publications here. These are already a few years old, but there are new publications coming out, and I can see that I've used my time, so I thank you and finish here. Thank you very much.
Thank you very much, Jukka. And okay, you know you are 1 hour ahead. Thank you for being with us. I think your dinner was somehow disturbed. Okay, thank you to all the presenters. I would like to ask again if there is any question from the audience. Okay, I have a general comment. This session, I think it was very important for us because it was, you know, this project started in the beginning of the pandemic, and so we had not the possibility of meeting each other. And to know what we can do, we should know in detail what are our potentialities, and this was first aim of this forum was really to have a good overview of all the existing possibilities in the different locations. So, you know, here in the coordination of this work package, we have 3 engineers, 3 geographers, and a lawyer. Of course, in the teams, we have many other competencies besides, for instance, in the University of Coimbra, we have people from architecture and from other fields of engineering and also from economics related with this project. So, I think here in the challenges that somehow were presented, we can feel that there are already quite precise ways of collaboration. So, from my point of view, I think our objectives for today, we could achieve them. I don't know if any one of you want to make some comment. I think that, for instance, with the University of Salamanca, this collaboration regarding the law aspects are really very important, because when we talk about cultural heritage, this is like having an intervention in this type of building is a very difficult task from the point of view of the law in many countries. So this is something that we will need to discuss. And also, I see the responsibilities in the case of the people that will have problems on account of heat waves need to be studied also from the legal point of view. So this is just one example of a potential collaboration that we can see. And for instance, Miriam presented. This software was developed at.
Not at the university, but it is used at the university.
Mm-hmm.
It's a French software, but we could also use other one to compare the results, such as Energy Plus.
Yeah, so if there are no questions, okay, there is a question. Thank you for being a beginner. Okay, I don't think it is out of scope, because even now with the pandemic, we came to the conclusion that there are effects of the environmental conditions on the propagation of the diseases. And okay, I'm married with a nurse who works in the emergency section of a pediatric hospital. And so, depending on the conditions that we have, she is complaining more or less about the number of patients that who were coming to the hospital. So sure, there is a strong relation, and I may say that I've been talking with the coordinator with Daniela, the coordinator of our work package, and I think that we have some interface topics that deserve to be treated by both virtual institutes. So it's something that is in our plans.
So if I may add to this, I think I agree that there's a real opportunity to work on this within this virtual institute, but also across institutes. So I already had some conversations with Ricardo Almendra, who works on health and climate, and Yuka also referred to this topic. So what we, for example, as geographic information scientists can provide is downscaled climate projections or climate reanalysis data for the past, projections for the future, and to take that to the neighborhood scale within medium-sized cities, and then where we would normally stop is to say, okay, this is the frequency of certain weather extremes, and this is known to be an issue, a health issue for a variety of diseases. But I think in collaboration with colleagues who more specifically work on the health effects, we can also be more specific about the which diseases might become more frequent under what kind of climate conditions, and then of course what adaptation measures could be used to prevent that from happening, right?
Any other question? Yes, Luisa?
It's a provocative suggestion because with my background. So normally when we talk about climate change, we are much focused on heat waves. And because of the condition of the full poverty of many of the southern countries and maybe also in the UK, we know that the winter effects are much higher. Last winter, we had a huge example in Spain of the problem of the cold waves, not so much of the heat waves. And my words to you are in the sense of not letting these parts go into the project, because we have been watching the problem of the heat waves, but we don't know, as the climate is changing, the reality will change much in terms of the conditions of the winter, because somehow we know that when it's hot, we tell people to stay inside, even if they might feel wet inside during the summer. But during the winter, with condition, with the buildings conditions and the capacity to heat the homes and roads connected with the energy, I think that if you could do it, because I push for it in terms of the full poverty issue and conditions of the building construction, at least in certain parts of Europe, so that countries are more
prepared. Yes, thank you very much. I think we should change the title to Positive and Negative Heat Waves. But sure, you are right. In the in South Europe, sometimes we have more problems with cold waves in terms of the number of penalties than with heat waves, because we are somehow more prepared to heat than to cold. So maybe I think we should finish in a good time to the dinner. So thank you very much, everybody, for your presentation and your courage to survive till this hour. Thank you.